I'm Christina Fuges with MoldMaking Technology, and today I am here with John Bozzelli, who is the owner of Injection Molding Solutions, and Rich Oles, who is President and CEO of ALBA Enterprises. Welcome, gentlemen.
Good to be here.
For this one, I'm pretty much going to let these two talk. So we're going to talk about processing and mold making, and pretty much around the umbrella of data, right? The importance of data.
And how you use data to maintain a process, and John will take the lead.
Okay, first of all, we're going to start out with some of the basics of molding and developing a process. I strongly recommend you keep it simple as best you can. First part of it is I talk about a viscosity curve, and what I want you to do is shoot a part that is, develop a part that's 96, maybe 98% full. You can see that it is short, visibly short, by volume, not by weight, right? Visibly short. And then you go through your speeds from very fast to very slow. You develop a viscosity curve, and from that you can develop an idea of where you want to be on fill time. How do you do that? You lay all these parts out at these different speeds. And if there's a change in the visible part, good or bad, you'll see if speed influences that. If you see no difference other than size in the parts, guess what? You're lucky. Just use one speed. Don't use the 10 profiles that make it complicated that the machine's got on front of the front page. Keep it simple. 90% of my jobs are one speed.
Okay.
And if there's something wrong with the part, sometimes you can fix it. So develop that, and then you can then you start melding at 98% full part at the fill time that you want, that you pick from the viscosity curve. And you start looking at the pressure required to do that. And you're making parts, you're consistent, you see it. How much is the pressure varying? It should vary. It should not be the same pressure every shot, which bothers some people, but there'll be a range, and that's nice to establish, because when it goes out of the range, that's going to tell you need to do something to the process. So once you've got your first stage set up, now you're going to add pack and hold. Folks, if you got a velocity pack,
that's what we were talking about.
all I can say is, folks, this is bogus on 90% of the machines that have it. If you have a velocity pack, you got to make sure that the pack pressure dominates, not the velocity. There are some very few times you want to control how fast it drops from first stage to second stage. That's still possible even by time, but velocity is nice. But do not use a velocity pack for most cases. Keep it simple. You use a pack pressure that packs the part out to the size, shape, dimensions that you've got to. And one thing while we're on this, real trick, make your life easier, watch fill time. That should not change by more than 0.04 of a second, plus or minus 2, right? Watch the pressure. The pressure will tell you if you change colors, if you change grades, if you change blocks. It'll tell you if that is different than what you've been doing. The pressure is either going to stay in the same range, go below, or go high.
Okay.
It's easy. If it goes high, that tells you that the pressure, that plastic is stiffer. You're using more pressure to push it to the same point. Therefore, you can go to your hold pressure and make the part the same size by probably raising. How much do you raise it? I can't tell you, but you're at least not fooling around with temperature, velocity, and whatnot. It's a good starting point. Basics, and it'll get you where you want to go. If the pressure goes down with the new lot or whatever, it means it's easier flowing. In order to make the same size part, you should pack it out less. How much? Again, I can't tell you. Experiment within 4 or 5 shots. I bet you can get it, and then run.
When that pressure drops, one of the things John and I talk about from the tooling side to the mold, if the pressure drops, it means the viscosity of the resin is lower. So the lower the number of viscosity, the value, the easier it flows, and the easier it will flash.
That's true.
So
what
you look at is if you're packing the part out. John monitors 6 key variables. There's 600 you can do.
Right.
John monitors 6, and that's what we teach at ALBA too for scientific molding.
But how did you end up identifying just 6?
Oh, decades of it.
Decades
just
of
narrowing it down, narrowing it down.
I'll be honest with you, I've instrumented a lot of molds with cavity pressures and whatnot, and that's very expensive. If in critical issues, it's life and death situations, Like I molded a filter for lung transplant patients. If the filter fails during the operation, the patient dies.
Okay.
All right?
That's
All
serious.
important.
Yeah. That's a good
When
example.
I went into that one, they asked me to do it. It said, you're going to have a cavity pressure in the cavity, or I'm not doing this. The liability is just too high. Cavity pressure always proven. They can verify we made it to spec. So, but you know, most jobs don't need it. Critical jobs, certain ones do, and do it when you have to. But keep it simple if you can.
You can tie in all these variables that John monitors. You can look at your transfer pressure, and if it lowers, you start looking at into fill of the part. You may have done a simulation, vents are applied, and if somebody was a little heavy-handed putting the vent in, at the higher pressure, higher viscosity, it may not flash. And if you change lots of resins, all of a sudden you now have a problem. And what the trap is that some process engineers, probably the majority, will maybe start changing the process. Instead of identifying the root cause, and
yes.
this lot of resin now is a different viscosity. So we actually had critical medical device OEMs that we work with that literally will take that lot of resin, they'll check viscosity before they run. And if it varies, they won't put it to the machine. Other companies don't do that, and then they're reacting to those situations.
That's a recurring theme all the time.
Another aspect of this, we don't want to be over-pressurizing the mold. That pounds the parting line, and now your tool will last longer. You don't need to have it go into the shop, and you don't have to worry about this. Well, you still have to worry about flash, but it'll keep it down. It's not going to wear.
Mold makers hate process engineers that solve problems by increasing pressure when they don't have to.
Okay.
Sometimes you have to, but if you don't have the tools in your toolbox, literally, to know how to adjust the process so you don't abuse the mold. The other one that's just a constant trap we see is if a machine's capable of 250 tons, the mold requires from simulation and experience maybe let's say 125 tons. They still apply 250 tons of pressure, and it might be a small mold, and you crush the parting line, so your venting changes over time, and then ultimately, now your process is no longer stable.
Where's the tool?
Where's the tool out? You get a burr. You don't have to do that. So if you're monitoring those 6 key points, you'll have those indicators.
So that's a great, when you keep saying simplify, like keep it simple.
Simple.
It's just having that process and following that.
Yeah, but there's so many different numbers that we can punch in the machines. If you ever see a processor, they love punching numbers to see what's going on.
Knob twirlers sometimes.
Knob twirlers.
They just love that. But if you keep it simple down to these 6 principles, and put away some of the, being honest, a lot of machine manufacturers have so many things. I have a brand new machine, and I can show you 30 different set points that don't change a thing.
Wow.
It's
looking
noise
over the
in
shoulder.
a lot of ways. It's just noise.
But where does all that come from? Like,
Well, it comes from, in my opinion, and John can expand on it, some of it comes from just because you can, and then other parts of it come from one customer needed this one feature because it has such a specialized application. And it's such a cool feature, we got to put it in every tool, or every machine. And it really doesn't get utilized by the masses. So it becomes a distraction, and it actually becomes confusing. There's a lot of great processors out there who may have been given bad training or just don't know. And when you get
no
them,
training, because
no training.
it's so hard.
They've been thrust into this world and make it work. Here's a new machine, we're not going to train you on the control. Education is key, absolutely key. Well, because it doesn't happen, people like John and people like me, our company always still consults all the time. We are called constantly.
Well, how did you guys hook up? Because you have the same training philosophy, right?
Well, mine's based off of John's scientific molding principles, but I have the tooling background, the hot runner manifold
Nobody
background.
can know everything,
Right.
right?
Of course.
And so I got involved with you from the hot runner
sides and
fixing
thermography,
hot runners,
thermal imaging.
right? Thermal imaging, which I got, I really like infrared technology.
I can see you liking that.
It does.
Bought the camera. It's a heat-based process, and it tells you something. So, you get the data for whatever could be wrong, and you go find people that are knowledgeable in that area. And this guy was, you were fixing hot runner systems. I don't know. I would love to know everything about it, but you only can know so much. For whatever reason, I like processing. He's been into the tooling aspect,
and mechanical side of it.
So you find a core group of people, like Bill Hartwick's not here, but he's a hydraulics guy and servo motor guy. You can't know everything. Admit it. Go get help.
Yeah, that's true.
Well, it takes a community to raise a kid, and every project's a kid in a way.
Yep.
And so the first time I ever met John, I was working on a 25-drop hot runner manifold, bridged, sequentially valve gated, that was doing a chrome-plated grill for a semi-truck. And it was, 10:30, 11 o'clock at night? And he was, the late John Lefebvre was a friend of ours, common about thermography. And John had told him, hey, Rich has got killer good coffee right off of exit 23 in Michigan, off I-94. And 10 o'clock at night, I get this on my door, seriously. And then we were in there till 1 o'clock in the morning? I showed him the thermography, and that was the start of this relationship.
I never heard that story.
Yeah, that was back then.
I have even some of the slides in my seminars that I give.
From us.
From that,
Yeah.
that's cool.
Yeah, so we
Now wait,
found,
what made you respond that quickly to this request?
That's Bozzelli. I want to get it done, and I want to go home.
Yeah, exactly.
I love
And I
it.
need the expertise, and if I know who the expert is, I will
There's gotta be
bribe
a level
them.
of
I will
trust.
give them money. I'll do anything just to
Yeah.
get it done, because you can't
It
know
bothers
everything.
you. I need to have it fixed.
Well, and
Well,
I'll
it's
tell-
also manufacturing. I will say that
Yeah.
since I'm on camera, I dearly believe manufacturing and supply source here in the United States is important, and it's one of the things I've tried to help along with plastic manufacturing.
No, absolutely.
It's an important industry. Government's not paid enough attention to it, and we need it. I mean, look around, and plastic's not all bad.
Exactly. Say that again.
It's
Yeah.
not all bad.
Yeah, plastic
you
is
take
not
a look
all
at
bad.
the energy thing. Plastic, raw materials for 90% of it is natural gas. We're separating it and trying to sort it and whatnot, chop it up and put it in a coal-fired plant. Your pollution would go down. You get more heat content out of it.
you have to burn it at a certain temperature, though.
Right. It'll burn a little hotter.
Depolymerize, otherwise it's going to create all kinds of pollution.
Well, a lot less than sulfur and all the, you'll find
Correct.
less.
It's all
Coal's got
about perception.
mercury, metals in it. This is actually purified, most of the, except for the colorant, and that's minor. That's usually less than 2%.
Yeah.
Do you speak about that when you go around doing your workshops or training?
We spoke about it at the
Did
Tech
you?
Talk Theater.
Okay.
I
So it
really
comes
don't
up.
understand. I can show you videos of a guy in the Philippines who pays people to go to the dump, pull out plastic. He degrades it in by pyrolysis in a non-oxygen tank, breaks it down to diesel fuel and kerosene,
Converts it.
and sells it for less than what they can ship it in for fuel.
Yeah, it's pretty
It's-
crazy.
That is
It's
crazy.
pretty crazy. You know,
So do you have a training coming up together? Are you guys working on anything?
It'd be nice if we could combine it, but we all have different schedules. I have a training course that I do once a month now in my own little cubby hole in middle of Michigan, if people are willing to come that far.
then we actually promote it. We do the email blasts
Yeah.
Okay.
with John,
Very
and
much
he's on.
thank you for
and-
that.
well,
That's
absolutely.
great.
And John's on our website as well. We've got all the links, the banners of when his events are. So if you go to albaent.com and then media, everything's there. Actually, the MoldMaking Technology, pellet to part
I see
articles
that.
are all there.
Thank you for
and
that.
That's what we.
That's where that ties this all in too.
Absolutely.
That series connected the dots between those two worlds
Oh,
too.
absolutely. Yeah.
It was
Yeah,
good.
it's-
So is there anything you want to leave the audience with?
Try to keep it as simple as you can.
Yeah.
It's
Keep
it simple,
complicated.
stupid.
Keep it simple.
Yeah, that's really
Get-
that's it.
Get technically qualified help for your problems. Do not let people with a good BS.
He's trying to use the right
I know.
words.
You can say it. All right, before I let you go, remember I told you, I hope you were thinking while you were sitting here. Here's our t-shirt with a hashtag Mold Make a Difference. John, fill in the blank, Mold Make.
A better, easier life on the machine.
Oh, a better, easier life on the machine. I like that.
That
Oh,
was
and
unique. Mine was
good.
everything, but everybody said that.
Mold
so.
Make it. You gotta do better than that.
I didn't put the effort in.
All right, well, there you have it.
Yeah.
Rich has got nothing. Molds make everything. We've heard that 6 times today. But John's was good.
Yep.
Say it again, John. Molds make,
Your life easier.
and there you go. For everything mold making, visit moldmakingtechnology.com.